Okay guys, so after understanding that is what kinds of loads we will use in case of strength of material, now we will try to understand that is what is the effect of different kind of loadings when the member or component is subjected under it. Okay, definitely the behavior or the effect of different type of loading will produce different in case of components when the components are subjected under it, and this concept will definitely help you throughout the strength of material subject. Okay, आप जैसे ही लोड को देखेंगे, okay, this is the load, then you can clearly understand that is okay, this load will produce this kind of effect, और आप easily प्रॉब्लम को डील कर पाएंगे. Obviously, when I will tell you that is about the loading or effects of loading, in that case I will use the stresses formula. Okay, जो basic formulas है मैं आपका इसमें यूज करूंगा. Definitely we will drive those formula when we will deal with the different type of stresses. Okay, हम वो definitely deal करेंगे, but here I will use the direct formula for your better understanding, that is what kind of stress also induced in the member when it is subjected to the loading. Okay, कि जब वो इसके अंदर subjected है तो किस टाइप के स्ट्रेस उसमें पॉसिबिलिटी आपके इसमें इंड्यूस हो सकते हैं. ओके, सो द फर्स्ट आई विल स्टार्ट, we are not taking the with respect to time, that is static and dynamic load. Okay, we'll start our effects of load with respect to direction, that is normal and shear. Okay, so first I will start with the normal loading. Okay, तो नॉर्मल के साथ में मैं स्टार्ट कर रहा हूं आपके पास में नॉर्मल लोड. बेसिकली यू कैन से दिस इज द विद रिस्पेक्ट टू direction. Okay, so the first category is normal load. We all know, जैसे मैंने आपको बताया था, that is normal load is the load which will act normal to the cross section of the member. That will be the normal load. Okay, now in the normal load I told you about the two categories. Okay, so the first category was axial load. So first we'll take the axial load here. Okay, so first I'm taking the effect of axial load. Okay, so what is the axial load? We all know that is axial load is the normal load first of all, and definitely it will act along the axis of the member. ये member के axis के साथ में आपके पास में act करने वाला. Okay, that is the longitudinal axis. So let's try to understand that is what is the effect of this load on the member. So let's suppose this is our member here. Okay, this is our member here. बेटर कि आप लोग साथ साथ में ड्रॉ करते हुए चले. This will be beneficial for you. So this, let's suppose this member is completely constrained or restricted or fixed from one side. We can say this is the fixed end and this is the free end. Okay, obviously this is our x-axis. You can see here this is our y-axis here. Similar here, this is our x-axis. This is our y-axis here, and this is our z or z-axis. You can say here. Okay, now. So in this case, we are discussing the axial load. So let I'm taking an axial load here. Obviously, the nature of the load is tensile. Okay, that I'm saying this load is P load. So there's a tensile load that is acting on this member. Obviously, this load will try to elongate this member. Okay, this load will try to elongate this member. Okay, it will try to increase the length of this member. So you can say effect क्या होगा आपके पास में? So effect will be you can say elongation of member. Okay, definitely in this case I'm considering the tensile load. When there is a compressive load in this case, then there is a compression in this case. So you can say there is a elongation as well as compression of the member. Okay, so in this case there is elongation and compression. So obviously in this case this will try to elongate the member. So let's suppose in this case I'm saying after applying. So let's suppose the initial length was L here. Initial length is L here. So after applying the loading or axial load, there is a little bit change in the length of this component. Let's suppose I'm saying this is delta. Okay, so in this case this will elongate this one. Now obviously when this member is subjected under this one, then definitely the stresses will induce in this case. And now in this case the stress induced in this member will be the axial stress. Okay, जो stress हमारे पास में induce होगा क्या होगा? Axial stress. So बेसिक जो इन्फॉर्मेशन हमारे पास में है थोड़ा सा आपका जैसे मैंने आपको बताया था, आई विल यूज द फॉर्मूलाज हियर डायरेक्टली टू क्लैरिफाई यू ऑल द थिंग्स. सो वी कैन से द एक्सियल लोड इज सिग्मा इज डिफाइंड एज लोड अपॉन एरिया. What kind of area that we are using here? Area is the cross section area here. Okay, cross section area हम यहाँ पे यूज कर रहे हैं आपके पास में, तो मैं डिफाइन किया. So in this case, the stress sigma will be equals to P by A here. P is the load here, and A is the cross section area of this member. You can see this is the cross section here. That is A here. Okay. Now, as the bar is prismatic here, cross section everywhere is same here. If you try to draw this stress here, अगर आप सोचें कि स्ट्रेस कैसे होंगे, सो लेट्स सपोज आई एम टेकिंग ए क्रॉस सेक्शन ओवर हियर. कुछ ये क्रॉस सेक्शन मैंने चूज किया यहाँ पे. आई एम कंसीडरिंग दिस इज अ क्रॉस सेक्शन हियर. ओके, दिस इज अ क्रॉस सेक्शन हियर. सो इन दिस केस इफ यू ट्राई टू ड्रॉ द स्ट्रेसेस ओवर हियर, दिस क्रॉस सेक्शन की व्हाट्स हैपनिंग ऑन ओवर दिस क्रॉस सेक्शन. सो इन दिस केस एक्सियल स्ट्रेसेस आर यूनिफॉर्मली डिस्ट्रीब्यूटेड स्ट्रेसेस. ओके, वो पूरे क्रॉस सेक्शन पे आपके पास में यूनिफॉर्मली डिस्ट्रीब्यूट होंगे. सो इन दिस केस एज दिस लोड इज टेंसाइल, ओके, सो इट विल ट्राई टू स्ट्रेस द मेंबर. So I am considering the direction of stress is just opposite to this one. ये necessary नहीं है. Obviously, when this member is cut like this one, so on this plane the stress direction will be in here. On this plane the stress direction will be here. They are exactly opposite to each other in direction. But for the understanding purpose, I am taking if this is the direction of load here, then stress will try to resist. Okay, it will try to resist this elongation. So they will be in the opposite direction. And as this is the normal stress. Remember, axial stress is a normal stress. आगे बात करेंगे हम उसकी भी डिटेल में, बट यहाँ के लिए. So this will act normal to this cross section. This will act normal to this cross section uniformly. ये इस cross section के आपके पास में normally act करेगा. It will be like this. Means this stress is actually uniformly distributed over throughout the cross section area of the member. ये पूरे cross section पे आपके पास में थ्रूआउटली यूनिफॉर्मली डिस्ट्रीब्यूट होगा आपके पास में. इट विल बी लाइक दिस. ये पूरे क्रॉस सेक्शन पर आप जहाँ पे भी देखेंगे इट इज एक्टिंग थ्रू आउट द क्रॉस सेक्शन यूनिफॉर्मली हियर. ओके, आप कहीं से भी ड्रॉ कर लीजिए इसको. लेट्स सपोज इफ यू आर ड्राइंग अ मेंबर हियर, देन इट विल लाइक दिस वन, देन इट्स लाइक दिस वन, इट्स लाइक दिस. सो एज द लोड इज टेंसाइल, आई एम ऑल्सो सेइंग द एक्सियल इज दिस. आई एम सेइंग प्लस हियर बिकॉज दिस इज प्लस P by A here. Okay, so in this case the distribution of stress will be completely uniform. Okay, it will be completely uniform throughout the section. One more thing, in this case when you move from cross section to cross section, जैसे आप क्रॉस सेक्शन से क्रॉस सेक्शन पे वेरी कैंडिडेट, सपोज इफ यू आर at the free end, if you are in between here, if you are at the fixed end, in this case the axial stress value is not going to change, it will be same here. Okay, that is by the Saint Venant principle. Okay, ये हम बात करेंगे आपके पास में जब हम बात करेंगे axial stress की. So due to the Saint Venant principle, we are simply considering that is the axial stresses are uniformly distributed throughout the length of the member or component. Okay, ये आपके पास में throughout इसके अंदर क्या है, distributed है. Now, so if I take a कंप्रेसिव लोड, ओके, तो मैं यहाँ पे आपके 2D में ड्रॉ करता हूँ. आई थिंक यहाँ पे आपको ये समझ में आ गया होगा कि हमने क्या बात की यहाँ पे. इन दिस केस इफ आई एम टेकिंग ए लोड इज कंप्रेसिव इन नेचर, सो दिस आवर लॉन्गिट्यूडिनल एक्सिस हियर. लेट्स सपोज आई एम सेइंग हियर इज आवर लोड. लेट्स सपोज दिस इज Q here. Obviously nature is compressive in this case. So in this case there is a compression. So if this initial length was L here, so there is a compression of the member, and in this case this member is going to be compressed like this one, led by an amount delta here. Okay, delta amount से आपके पास में compress हो जाएगा. So in this case if you want to define or try to draw the stresses in this case, so you can see here this is the direction of compression here. So if I am considering this is a cross section here, the stresses will act normal to this one in opposite direction. Okay, it's like this. So I am considering this is a cross section. Okay, in this cross section the stresses are uniformly distributed, try to resist this compression. In this case the nature will be of axial stress will be negative in this case, as the loading is negative here. A is the cross section of the member. Okay, so means the information we collect here for the effect of this axial load, it's simple. Means there is either elongation or compression of the member due to the loading, depending completely upon the loading, and the axial stresses will be induced in the member and remains constant throughout the length or throughout every cross section over the मेंबर हियर, ठीक है, वो पूरे मेंबर क्या लूंगा आपके इसमें वो क्या रहेंगे, फिक्स रहेंगे, चेंज नहीं होने वाले। ओके, देयर इज नो नीड टू वरी कि फॉर्मूला कहां से आया, मुझे पता है कि आपने थोड़ा बहुत पढ़ा है तो आपको पता होगा एटलीस्ट, वी विल डेफिनेटली ड्राइव दिस वन, हम ये सब कुछ ड्राइव करेंगे। ओके, दिस इज द क्लासेस फॉर द बेसिक्स, ठीक है, बेसिक्स की बात करेंगे। इन दीज बेसिक्स डेफिनेटली विल गेन सो मच कि आपकी हाफ सम तो वैसे ही खत्म हो जाएगी। ओके, नाउ ओके, लेट्स मूव टू आवर नेक्स्ट type of load. Okay, so the first type we consider here the axial load. Then what is the second type of normal load here? So second type we know the eccentric axial load. Okay, so the second type we will consider here is eccentric axial load. So the second type is eccentric axial load. Okay, this is our second type. Now you will see that is how when the axial load is having little bit eccentricity, then how its effect is gonna change. Let's take a look. Okay, so that I'm considering again, this is our member here. This is our member here. डायग्राम से जो आपकी माइंड में क्लियरिटी आएगी वो आपको एक बेटर वे में लीड करेगी। फॉर्मूला तो हर जगह लिखे हैं, ओके, कहीं भी किसी पढ़ लीजिएगा, बट यू नीड ए क्लैरिफाइड कॉन्सेप्ट। सो अगेन आई एम कंसिडरिंग दिस इज आवर मेंबर हियर, एक मेंबर की हम बात कर रहे हैं यहाँ पे। लेट्स सपोज आई एम फिक्सिंग दिस मेंबर फ्रॉम वन साइड, लेट्स सपोज दिस साइड इज फिक्स्ड वन, this side is fixed one, this is our x-axis, this is our y-axis, this is our x-axis, this is our y-axis, and this is our z-axis. Okay, this is our z-axis. Now, okay, so we are talking about an eccentric axial load. So obviously this load will not act along this one, but having some eccentricity from this one. So let's suppose I am saying this, there is a load here like this one. There is a load here like this one. This load is P load, obviously tensile in nature. Let's suppose having eccentricity E from the longitudinal axis. Okay. Now, what kind of effect this load will produce? Okay. तो load आपके पास में क्या effect produce करेगा? So before going to effect here, let me tell you one thing more. यहाँ पे एक चीज मैं आपको और बता दूं। Let's suppose there is a tap, एक टैप है, एक नल है आपके घर में, एंड वो टैप आपके पास में खराब है, द टैप इज नॉट वर्किंग। ओके, यू वांट टू ओपन द टैप, सो लेट्स सपोज दिस इज द पाइप ऑफ द टैप एंड देयर इज अ टैप हियर, एक टैप यहाँ पे आपके पास में, यू वांट टू ओपन दिस टैप, आप इसको इस टैप को ओपन करना है। सो यू हैव टू ऑप्शंस, आइदर यू कैन यूज द नोज प्लायर, ठीक है, आप एक आपके प्लायर का यूज कर सकते हैं, और यू कैन यूज ए पाइप रिंच, एक पाइप रिंच का भी यूज कर सकते हैं। ओके, यू हैव टू ऑप्शंस। सो मीन्स लेट्स सपोज इफ दिस इज द pipe, okay, and let's suppose here is a tap that you want to open, okay, आपको इसको ओपन करना है। So in this case let's suppose you are using a plier here, आपने plier यूज किया इस पे, ठीक है, and then you are applying a load over here, आपने एक load apply किया इस पे by your hand. So this is the pipe here, here is the plier, and you are applying a load here like this one. Okay, so when you are applying a load here, in this case definitely there is a moment will produce here. So let's suppose P is the load and A is the distance. P is the load and A is the distance. In this case, a moment is going to produce about this line. That is about the axis of the pipe. There is a moment here. And the moment value in this case will be equals to P into A. We all know load multiplied to the distance from here will be the moment here. So this moment will work to open this one. But after creating this moment, this load will create this moment here about this one. Now this load will transfer, okay, ये load आपके पास में transfer भी होगा, this load will transfer at this point. So actually when you are using a plier in this case, so at this point you are having a moment, also you are having a load P here, एक load P भी यहाँ पे आ जाएगा. This load is gonna shift here after creating a moment. This load is transferred here, that is here. It means when you're using a plier here, There is a twisting moment that will open this tap, but also this load will try to bend this pipe. Okay, ये जो load आप लगा रहे हैं, this load will try to bend this pipe. ये इस pipe को bend करने की कोशिश करेगा. So when you are using a plier to open the tap, in that case there is a chances that you can break the pipe. उसके इसमें आप pipe को तोड़ सकते हैं, ये आपके इसमें चांस होगा. Okay, so when this type of system happen, then you can say there is a moment here and load is also going to shift at the center of moment. Now, if you use a pipe wrench, okay, so if you use a pipe wrench here like this one, obviously this distance is also having a here. Okay, now you are doing what? This is the pipe here, then you are using a pipe wrench, you are fixing both sides, then you are applying a load like this one. Okay, now there is a pipe wrench. It means from here that you are applying a load P by 2 downward. Okay, this moment will be like this one, and also you are applying a load here that is also P by 2. Okay, now this load is like this one. Okay, you are applying like this one. Okay, now so P by 2 from this side, P by 2 from this side. Now what will happen at this point? Okay, what will happen at the center of rotation? So obviously there is a moment here, there is P by 2 into A, that is here. Okay, ये होने वाला आपके पास में, that is anti-clockwise. Also P by 2 into A, this moment is also in this case. So in this case the moment that is going to produce here, the moment यहाँ पे produce होने वाला है, that is what? That is P by 2 into A plus P by 2 into A, because both the direction of moment is same here. Okay, in this case I'm adding these two, and in this case you can say this is twice of this value here, so 2 is going to cancel out, this is PA. So this moment in this case also is PA. Like previous case the moment is also PA, but now at this P by 2 gonna shift over here. Okay, this P by 2 gonna shift over here in the downward direction like this one. This is P by 2. Also this P by 2 also gonna shift here. This is P by 2. So you can see in this case equal and opposite forces are gonna shift at the center of moment. So in this case there is no net load is available at this end of the pipe. These two loads are going to cancel out each other. It means there is no bending is produced in this pipe. इस pipe में आपके पास में कोई भी bending produce नहीं होगी. This is a pure couple. So by using the pipe wrench without breaking the pipe, you can easily open the tap. Okay. यहाँ पे मैंने आपको क्यों बताया? Because here I want to tell you about moment. Okay. So in this case, this is a pure moment, because in this case these two loads gonna cancel out. But in this case, this is not the pure moment, because in this case P is available here. ठीक है, यहाँ पे P आपके पास में available है. Now let's check out this system here. Now you can see here, as P is the load here, this is applied at the eccentricity E here. So when this load is applied like this one, so this load, this one and this distance will create a moment. It will try to bend this one about which? About x-axis. Okay, about x-axis. So there is a moment is going to produce about the x-axis here. एक moment यहाँ पे produce होगा, that will be about x-axis here. So in this case, there is a moment like this one. This is about this x-axis. And what will be the value of this moment? This is P into perpendicular distance, that is E. So there is a bending moment is produced in this case. I will tell you about more about the bending moment when we move further here. But in this case, there is a couple is or moment is going to produce about the x-axis. That I am saying as this moment is producing about x-axis, I am saying this is mxx. This is P into E here. Now, as in that case, the load going to transfer at that point. Similarly, this P load is also going to transfer at this point. Okay, so the P load will also going to transfer at this point here. So in this case, this eccentric axial load will create two things. It will produce a moment and the load going to transfer at the center. We know if there is a load is acting, axial load like this one, like the previous case. So in this case, there is an elongation. Okay, वो मैं discuss किया. So definitely in this case, there will be elongation. यहाँ पे elongation होने वाली है. But due to this moment, as this is our beam here, this is our member here, and this moment is like this one, about x-axis, this moment is like this one, it will also bend this one. Okay, it will also bend this one, इसको bend भी करेगा. It means there are two effects here. Okay, effects क्या होंगे? First one is elongation or compression of member. Second, bending of member or component. Okay, so there are two effects here. Means after the application of this load, इस load की application के बाद में ये जो member है ये आपको कुछ ऐसा दिखाई देगा. It will look like this one. It will look like this one. Okay, there is a bending effect here. Also, there is an elongation here. So, in this case, I am saying that this was the initial length of the member. Okay, and this is our axis system here. So in this case, this is our z-axis that is completely bent like this one. This is x-axis, this is y here, this is z here, this side is fixed here. Okay, this is due to what? This bending is due to this moment. So initial length was L. Okay, so initial length was L here. Initial length was L here, ठीक है, L आपके पास में. And there is an elongation of member. Okay, there is an elongation of member, that is delta here. So there are two effects in this case. There is a bending here, bending हुई आपके पास में. Also, there is an elongation of member. Okay. Now, अब क्योंकि bend भी हो रहा है और elongate भी हो रहा है. So we all know, due to the elongation or compression, the stresses are axial stresses. But I think we also know one thing about the bending stresses. Okay, so bending stresses are due to the bending of the member. ठीक है, member जब bend करेगा, then the bending stresses are gonna produce. वो आपके पास में उस सिस्टम में produce होने वाले हैं. It means in this case, for this type of loading, there will be two types of stresses will be available, that is axial stress and bending stress. दोनों ही stress आपके पास में इस केस में यहाँ पे होने वाले हैं, and they will induce in the member simultaneously. दोनों आपके इसमें क्या होंगे? Simultaneously आपके पास में करेंगे. मैं आपको प्रॉब्लम्स करवाऊंगा, आपके पास में ऐसी प्रॉब्लम्स करवाऊंगा जिसमें आपके पास में काफी नंबर ऑफ स्ट्रेस लग रहे होंगे. अगर आप जस्ट करेंगे, that is from where the limit of or the strength of the material reached and the member is gonna crack or structure. Okay, so but definitely इसके मैं आपको प्रॉब्लम करूंगा. So how we can see those stresses? ठीक है, so first of all let me talk about the axial stresses. We all know this is P by A, that we know. I think इसमें कोई इशू नहीं होना चाहिए आपका इसमें. So in this case, due to this P load, let's suppose if I'm considering this is our cross section here, this is our cross section here, let's suppose. So in this case, obviously at this cross section, axial stresses will be available. And axial stresses will be tensile or compressive? Tensile. Okay, so in this case, you can see here. So, this will be our axial stresses due to the load P here that is acting at the center after creating a moment. Okay, so it will act like this one throughout the cross section. Any cross section you can take, there is no problem in this case. Like this. Okay, so you can see here that is this is, so over this cross section it's working like this one. Throughout the cross section they are working like this. So this is the axial stress. You can say this is plus sigma A is equals to plus P by A. Throughout same, you can check this point, this point, this point, any point. Here this is plus sigma A, here this is plus sigma A, here this is plus sigma A. Everywhere the axial stress will be same. That will be positive in this case. Maybe negative if the load is compressive. But what about bending? Okay, so let me introduce here. ठीक है, यहाँ पे जो आपको पहले से आपने पढ़ा है. So bending stresses are also the type of normal stress. Okay, that we are given sigma by y. आपको मैं फॉर्मूला याद करा दूं एक बार. Okay, let me write here. Sigma by y equals to. Okay, अगर हम बात करें पे bending stresses की, तो जब हम bending stresses की बात करते हैं तो हम क्या बोलते हैं? Sigma by y. Okay, और stresses are directly proportional to y. अगर आपको याद आए तो आपके इसमें, ठीक है. So sigma by y is equals to m by I. बेंडिंग क्वेश्चन यूज करते हैं हम लोग. ओके, m इज व्हाट? m इज द बेंडिंग मोमेंट हियर. सो m इज द बेंडिंग मोमेंट हियर. I इज व्हाट? I इज द क्रॉस सेक्शन हियर. ठीक है, ड्राइव करूंगा आगे डेफिनेटली, मैं आपको ड्राइव करूंगा. बट हियर, ठीक है, सो ऑब्वियसली इन दिस केस बेंडिंग मोमेंट. सो यू कैन सी हियर दिस बेंडिंग मोमेंट इज कांस्टेंट. इट्स नॉट वेरिएबल बिकॉज दिस बेंडिंग मोमेंट इज नॉट डिपेंडिंग ऑन द लेंथ ऑफ द मेंबर. It completely depending on eccentricity. So due to this eccentricity, this moment is produced is PE, that is fixed here. So this moment will be fixed throughout this length here. This moment not going to change here. I, cross section of the member, is also fixed here. So if you are taking y this direction, so in this case the moment will be about x-axis, and cross section I will take also about the x-axis. So as in this case, both moment and moment of inertia is constant. In this case, we can say bending stress is directly proportional to y. What is y? Y is the distance. Y, distance of fiber from neutral axis or neutral fiber, you can say. That is from here. ठीक है, अभी ज़्यादा समझने की जरूरत नहीं है, आगे डिटेल में बताऊंगा. So means simply we are saying y is the distance either from here or from downward here. So the distance of y increases this direction, also increases in this direction, will be 0 at this point. इस point पे 0 होने वाली है. Now, okay. So we know the bending stress is going to increase with the increase in y here. Okay. Now, and this member is bent like this one. Okay, you can see here. The member is bent like this one. I think in this in this case, the fibers. Okay, you can see here, there is a layer by layer development of this component here. So the fiber above this one, above the neutral axis here, are in tension. Okay, obviously when I will bend this marker like this one, above the neutral axis the fiber are in tension, and below this one are in a compression. Okay, so नीचे वाले compression में आ जाएंगे और ऊपर वाले किस में रहेंगे? टेंशन में रहेंगे. बार बार रिपीट करूंगा आपके इसमें, बहुत बार रिपीट करूंगा ताकि आपके दिमाग में चीजें बैठ जाए. Okay, so in this case the fibers above this one is what? Is in tension. Fiber below this one is in compression. It means the bending stress above this one is in tension in nature, and the bending stress below this one is in the compression in nature. तो इससे ऊपर जो बेंडिंग स्ट्रेस है वो किस में है? टेंशन में. इससे नीचे जो कंप्रेशन, आपके जो बेंडिंग स्ट्रेस है वो किस में है? कंप्रेशन में. ओके, सो इट मींस here the distribution. So I'm taking the same plane here. Again, I'm using the same plane here. Obviously on this plane the axial stresses are working, definitely they are working, but simultaneously bending stresses are also acting. You can see here bending stress is linearly proportional to y. The bending stress of क्या है आपके इसमें? Linearly proportional है. So when it's linearly proportional, so I can say that here the distribution of bending stress will be like this one over this cross section. Okay, it will be like this one. बताऊंगा बहुत आपका, मैं वैरायटी ऑफ प्रॉब्लम कराऊंगा तो आप समझ जाएंगे इस पे. So in this case, it's like this. Means at this section, if you draw a bending stress, it will be like this one. Okay, because from here to here y is increasing, from here to here y is decreasing. So at the neutral fiber, the value of bending stress will be 0, and this side it's going to increase in the compression. Okay, over this one, as this top fiber is having the same distance from the neutral fiber, the value will be same. This side it's look like this one, this side it's look like this one. Bottom fiber having the same depth from the neutral fiber, having the same value. So here this will be the distribution. This will be the distribution of bending stress. Let me draw here. Okay, मैं इसको यहाँ draw कर रहा हूँ. So if this is our cross section plane, if this is our cross section plane here, like this, on this one, the distribution of bending stress will be like this. एक side compression होंगे, एक side tensile nature के होंगे. So in this case, this is the distribution of bending stresses on this plane here, like this. It's like this here. Okay, so this is the distribution here. I am considering both the stresses on the same plane, so I can tell you the effect, combined effect. Okay, so I can say that is the stresses above this one are in tensile nature. So I am saying this is plus bending stress, plus sigma b. This is also plus sigma b, but this is compressive in nature. So I am saying this is minus sigma b. This is also minus sigma b. Okay, now on a single plane, एक ही plane पे there are axial stresses acting, all are positive. On the same plane, bending stress here is positive, here is negative. So at which point the member is having the maximum value of stress? Okay, so as both the stress, axial and bending, both are the type of normal stress, दोनों normal stress के आपके टाइम है, you can directly add them or directly subtract them. So you can see here, at this point, this is the value of sigma A and this is the value of sigma B. So at this point, the normal stress value is simply plus sigma A plus sigma B. Okay, both are going to sum up here. Similarly here, इस point की अगर हम बात करें आपके पास में, in this case also, here the value, let's suppose this point is point A here, this is point B here, something, this is point A here, this is point B here. So sigma capital B, both are positive, sigma A plus of sigma B here. Let's suppose this point is C here. Now you can see here, this sigma A is positive here, but sigma B is negative here. So you can say that is sigma C is equals to what? Plus sigma A and minus sigma B here. Okay, now you can check the value here. Similarly, if this point is the D point, you can say sigma D is equals to plus sigma A here minus sigma B here. Okay, so this is how that I'm writing the A here also. So this is plus sigma A here and plus sigma B here. You can see here like this one. So this is how at the different points. Okay, और अगर मैं 2 पॉइंट और मार्क कर दूं, let's suppose on this x-axis here. So obviously let's suppose this point is E point. This is F point. So obviously at the point E here, there is no bending stress. Okay, so you can see here at the point E here, the only axial stresses are available. Also at the point F here, only axial stresses are available here. Okay, so means at a same cross section, when you vary over the cross section, the value of stress gonna different. आपके पास में stress की value different होने वाली है. Means let's suppose if you check at this point, you can see here this is the value of sigma A, but here this is the value of sigma B, that is much less than this compared to this one. So means at the same plane, the value of stresses will be different. आप केस में क्या होने वाली है? Different हो जाएगी उस केस में. So means when you do the combined system, जब हम बात करेंगे कि principal stresses की, तब आपको लगेगा yes कि उस load की वजह से there was only single load, एक ही load था, but why there are 2 type of stresses or 3 type of stresses or 4 type of stresses? This is because the different type of loading. So in this case, the loading that we are using here is this one, that is the eccentric axial load. And you can see here, due to eccentric axial load, there are 2 loading system and the system is such a complex system. ठीक है, इतना कॉम्प्लेक्स होगा आपके पास में. Let's suppose 4 stresses are acting. Okay, 4 stresses are inducing in the system. The system is going to be much complex, and that's why we require the more circle और प्रिंसिपल स्ट्रेसेस और कंबाइंड स्ट्रेस सिस्टम. ओके, वो बहुत आगे की बात है. उससे पहले मैं आपको बहुत कुछ बताऊंगा और आपके दिमाग में एक चीज क्लियरली फिट करूंगा. और मैं आपको बता रहा हूं, सो लिटरली आपके लिए एक दिन का गेम होगा. ओके, सो आई थिंक दिस टाइप ऑफ लोडिंग, जो हमने बताया आपको पास में एसेंट्रिक ऑक्सियल लोडिंग, इसका जो इफेक्ट है दैट इज क्लियरली इन माइंड. अगेन मैं बोल रहा हूं, फॉर्मूलों को अभी ये मत सोचिए कि मैं फॉर्मूले कहां से लिया. डेफिनेटली आई विल ड्राइव ईच एंड एवरी फॉर्मूला. आपको सीक्वेंस अपने आप समझ में आना शुरू हो जाएगी. ओके, सो आई थिंक दिस कॉन्सेप्ट इज क्लियर इन योर माइंड.